this algebra video walkthrough lesson, we're going to take a look at function machines or input and output boxes and finding the missing output values. And this is standard 5083, setting up for that standard, and we'll be looking at this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our algebra video walkthrough section, and it's entitled Function Machines, Input Output Boxes, Finding the Output Value. Directions. Use the rule and the given values to find the missing output value. We have 4 different function machines. Let's take a look at the first. And we have a rule of multiply by 7, then subtract 5. And these are the input values. So we're going to apply that rule. I'm going to rewrite it over here. I'm going to apply the rule of multiply by 7, then subtract 5. We'll take the 1 and we'll rewrite this. 1 times 7 minus 5. 1 times 7, identity property there. You're probably thinking, ooh, that's 7. And you'd be exactly right. That's 7 minus 5 would equal 2. And there you go. So if you had a value of 1 and you applied this rule to it, it would output 2. All right, let's take a look at that next value over there on the chart. Here we go. It's a 2. So we'll apply the rule. So we'll take that 2 and we'll do 2 times 7 minus 5. 2 times 7, subtract 5. We have 2 times 7 equals 14. And then we'll subtract 5. 14 minus 5, 14 minus 5. We need to borrow here, so that becomes 0. It'll become 14. There we are. 14 minus 5. You're probably thinking that equals 9, and you'd be correct. So there you go. That would equal 9. Input a 2, output a 9. Next up, we'll take the 3. 3 times 7 minus 5 times 7 minus 5. 3 times 7, it's a basic fact you probably know. 21, if you're thinking that, good for you. Minus 5, 21 minus 5. You're probably thinking, I know that. Well, if you don't, you can always show your work, and it's always a good idea to do that to kind of prove you know what you're doing in math. Now we're going to borrow from this 2, that becomes 1. This will become 11. 11 minus 5 would be 6. 1 minus 0 would be 1. So that would output 16. Input a 3. Apply the rule. Output 16. Make some space here. You could print out page 2 of the worksheet, and it gives you some workspace. However, I'll just kind of make do with what I have here. We're going to input, this time we'll input a 4 and apply our rule of times 7 minus 5. 4 times 7 being 28 minus 5. So we'll subtract 28 minus 5. You might be able to do that mentally, and that's fine. However, we can show our work here. 8 minus 5 would be 3. 2 minus 0 would be 2, giving us an output value of 23. Input 4, output 23. Next up, we've got 5. Take a look at, write it down here, 5 multiplied by 7, subtract 5. 5 times 7, 35. Subtract 5. 35 minus 5, you should be able to do that mentally. You have 30 and you're going to take 35, 35, you're going to take away 5. That would leave you with just 30. Put that up in the table. On the output side. And we'll move on to the last. We have a 6. 6 times 7 minus 5. 6 times 7, basic fact being 42 minus 5. 42 minus 5. 12 minus 5 is 7. 37 we output there. Input 6, output 37 when given this rule. All right, that's number 1. Let's take a look at number 2. If I'm moving too quickly for you, feel free to pause the video and resume whenever you're ready. Also, you could just pause it, try it for yourself. I hope you would, and then you can check your answers right along with me. All right, now we have a different rule, and it is divide by 2, then add 15. We're going to first of all input a 2, so we have 2, and we'll apply the rule of divide by 2, then add 15. And you could really think of it as 2 divided by 2, first of all in parentheses, because that would be first in order of operations, then we're going to add 15. So let's do that. We got 2 divided by 2 is 1 plus 15. Definitely you could do that mentally. 1 plus 15 will give you 16. So we input a 2 and we're going to output 16. Next up we have 8 that we're going to input into our function machine. We'll take 8, apply the rule of divide by 2, divide by 2, add 15, see what we get. 8 divided by 2, division, let's see, we've got 8 divided by 2, and you could think to yourself, okay, 2 times what equals 8? 2 times 4 equals 8. So 8 divided by 2 equals 4. Then we're going to add the 15 to it. 4 plus 15, you could do that mentally. We've got 15 plus 4 more would give you 19. And that's what we'd output. You'd input an 8, output 19. Next up, we have 14 that we're going to input. So we've got 14 divided by 2, add 15. Again, we've got 14 divided by 2. You probably are thinking, well, I know that 7 times 2 would be 14, so 14 divided by 2 would be 7. Then we're going to add that 15 on. Okay, 15 plus 7. 7 plus 5 is 12, or 5 plus 7. And we have 1 plus 1 is 2. So we're going to output 22. We input a 14, and we output 22 when given this rule. All right, moving on. Let's make some space here so I can keep this chart up on the screen. All right. So we'll just take that 22. 22, apply the rule of divide by 2, add 15. 22 divided by 2, 2 times 11, if you're thinking that, good for you, would equal 22, plus 15. All right, so we've 15, we could add up those ones first, giving us 6 in the ones place, then these two tens, one here and one there, we'll have 2 tens, and then we'll output 26. There we go, we'll put that into our output side of our function machine. Now we'll input a 26. 26 divided by 2, add 15. 26 divided by 2. Really, if you're not certain about that, you could set up some traditional division maybe. 2 goes into 2 once. 1 times 2 is 2. Subtract, giving you 0. Bring down our 6. 2 goes into 6 3 times, so 3 times 2 is 6. Subtract, get 0 as your remainder. So actually we have 0 left over, and it goes in nice and evenly 13 times. So we'll put that over here, 13, because 26 divided by 2 is 13, or 13 times 2 equals 26. And now we're going to add that 15 on. Again, we can add the ones here, giving us 8 in the ones place, and 1 plus 1 is 2 in the tens place. Outputting a 28. Input a 26, and we output a 28. All right, let's finish this function machine up. We've got 32. Apply the rule. Divide by 2 plus 15. Here we go. 32 divided by 2. You might know that. 32 divided by 2, you could go through long division, or you might realize that 2 times 16 equals 32. You'd be exactly correct. So if you're thinking that, good for you. And then we've got to add 15 to that. So I know that 15 plus 15 is 30, and 16 is one more, so that would give us one more than 30, or 31. All right, moving right along here. Function machine number 3. We have a rule of multiply by 4, then add 8. We'll start with 3, 3, multiply by 4, add 8. 3 times 4 would give you 12. We're going to add more to that, 8 more. So we've got 12 plus 8. Well, I know that 8 plus 2 makes 10. That'll give us another 10, so that would be 2 tens, or 20. So there we go. We output 20. Now we've got, next up, a 6 we need to input in our function machine. So we'll do this right over here. 6 times 4. Here we're applying our rule again. 6 times 4 plus 8. 6 times 4 is 24. You're probably thinking that. Good. Then we're going to add 8 to that. 8 plus 4 I know is 12, and we'd carry up 1 over here, so 2 plus 1 is 3, giving us 32 on the output side. Then we'll take the next one here would be 7. 7 times 4 plus 8, that's our rule there. 7 times 4, 28, plus 8, 28 plus 8. I know 8 plus 8 is 16. Carry this 1 over, so 2 plus 1 would be 3, or 36. So we output 36 here. Input 7, output 36. Now we've got a 9 to deal with. We'll take care of that 9. We'll have 9 times 4 plus 8 is our rule. See what happens. 9 times 4, 36, plus 8. 8 and 6 I know to be 14. Carry that 1. 3 plus 1 is 4. So we're going to output 44. Moving right along here. And we'll take a look at this one. We'll input an 11. We apply the rule. Times 4 plus, oh, getting a little ahead of myself, times 4 plus 8. 11 times 4 would give you 44. Then we're going to add 8 to that. Let's see, 8 and 4 would give me 12 with a 10. So there's one more 10. 4 plus 1 is 5. 10. So that would give us 52. There it is. Now we'll input 12. Apply the rule, times 4 plus 8. 12 times 4. Well, I know that 2 times 12 is 24, and then we have two groups of those, so it'd be 24 plus 24, giving me 48 plus 8. I'm thinking, well, 8 plus 8 is 16 with a 10 here. Okay, so 4 plus 1 would be 5 tens, so 56 altogether. So we input 12 when we output 56. Look at that. All right, on to the last function machine with a rule of times 6 or multiply by 6, then divide by 3. All right, so we'll take our first input value and apply the rule. Okay, so let's do this. We've got 1 times 6. Let me just fix that multiplication symbol. 1 times 6. And we're going to divide by 3. Divide by 3. That's our rule. Multiply by 6, divide by 3. Let's see what happens. 1 times 6, a little identity going on there. 6, and then we divide that by 3. Basic division fact there. 3 times 2 is 6, so 6 divided by 3 is 2. Input 1, output 2. Let's see what happens to the 4. When we apply this rule, we've got 4 times 6 divide by 3. 4 times 6, you're probably thinking that's 24. Good for you. And then we're going to divide by 3. If you're not sure about that, use that inverse operation of division to help you out. So 3 times something equals 24. Well, I know that 3 times 8 equals 24. So if you divide 24 by 3, you have a quotient of 8. So there you go. So we input 4 into the function machine, apply the rule, and you get 8 as your output value. Let's look at this 8. We'll input 8 into our function machine with a rule of multiply by 6, divide by 3. 8 times 6 is 48. Divide by 3. Not sure what that is? Well, that's okay. You can just use division. We've got 48. Long division. Why don't we try a partial quotient this time? All right. If you're not sure how to do partial quotient, we have videos at worksheetsandwalkthroughs.com. They're there for you. Check them out if you need to. 3 times something would give us 48. Well, let's see. I like to work with benchmark numbers when we're doing the partial quotient method. So 3 times 10 would give me 30. Subtract. Okay, 8 minus 0 is 8. 4 minus 3 is 1. So we've got 18 left. Well, look at that. I know that 3 times something equals 18. It's a basic fact. We've got 3 times 6 equals 18. Subtract, and we would have no remainder, but what would our quotient be? Well, partial quotient, we've got these partial quotients that you got to add up together to get your full quotient. So we've got 0 plus 6 is 6. 1 plus nothing would be 1, giving us a quotient of 16. So 48 divided by 3 would be 16. Or 16 times 3 would be 48. All right, so we input an 8 and we output 16. What happens when we input 10? We've got a 10. We're going to apply this rule of multiply by 6, then divide by 3. Multiply by 6, divide by 3. 10 divided by, oh, I'm sorry, 10 times 6, of course, would be 60. 6 tens would be 60, and then we're going to divide by 3. 3, well, I know 3 times 10 would be 30. 3 times 20, or let's see how that works. 3 times 20 equals, well, I'm really multiplying this 3 by 2 tens, so that would be 6 tens, or 60. So there we go. 60 divided by 3 equals 20, because 20 times 3 equals 60. And there we have it. Input a 10, output a 20. Now we've got a 12. Now let me make some space to work in. All right, so we're going to input 12, apply the rule. So we've got 12 times 6 divided by 3 would be our rule here. Okay, 12 times 6. Not sure what that would be. It's a good thing to show. It's good. And let's try that again. You've got a 12 and you want to multiply by 6. You can show your work over here. Let's take a look. Let's see, 12 times 6, you could solve it traditionally. So 6 times 2 would be 12. 6 times 1 would be 6 plus 1 would be 72. All right, so now we've got 72, and we're going to divide by 3. You might not know that off the top of your head, so here we go. Let's solve it. 72, and we'll try the traditional algorithm. Why not? So we've got 3 goes into 7 twice, because 2 times 3 equals 6. Subtract 7 minus 6 equals 1. We'll bring down that 2. 3 goes into 12. 4 times 3 is 12. Subtract 0. All right, so now we have realized that 72 divided by 3 is 24. 24 times 3 would equal 72. So we output a 24 when inputting a 12, and we applied that rule to it. On to the last one. So we've got 15 and a rule of multiply by 6, divide. All right, let's try that again. 15 and a rule of multiply by 6. See, we all make mistakes. Here we go. Let's just keep moving on. All right, so we've got 15 times 6. Again, you might not know what that is, so why don't we try the distributive grid method. We've got 15, which consists of a 10 and 5 ones, and we have a 6. So we're going to multiply those. All right, so it's a 2 by 1 grid. So we've got 6 times 5, or 5 times 6, would equal 30. And now we're going to multiply 6 times 10 would be 60. Now we've got these we need to add right up. Probably thinking that 60 plus 30 would equal 90, and you'd be exactly correct. 90. And 90 divided by 3. Ah, look. Well, I know that 9 divided by 3 would be 3. However, it's 9 tenths, so 90 divided by 3 would be 3 tenths, or 30. And that really works out nicely because 30 times 3 equals 90. So we output 30 in this case. And you are done. So that was a quick look at finding the output values when looking at function machines or input and output boxes. Thanks for checking out worksheets and walkthroughs.com. We'll see you again next time.